This is why we've built Flare. We've built Flare to basically be a base layer for data, secured by the layer itself. Absolutely the first main layer one that acts as a data provider network. The core aspect is how you secure that oracle. It's embedded into the network, so it's part of the network. And this is where it gets its security from. Key difference between us and other oracles is that our oracle is secured at the blockchain layer with the main token of the blockchain. And that is a totally different way of securing an oracle, a substantially more secure way of securing an oracle. The FTSO, the pricing has been really very accurate. It is designed to be able to withstand a very large amount of malfeasance amongst the participants, whereas these ideas are not inherent in any other oracles. There is often trusted, or if they're using their own token on a blockchain, it's very, very much harder to get that level of decentralization. It's very hard to be able to get so many participants. Most smart contract platforms could not handle the number of participants we have and the amount of data we have. So that's... why we've built Flare. We've built Flare to basically be a base layer for data, secured by the layer itself.
Welcome to the DeFi Standard, and this is Mickey B. Fresh.
That is native to Flare, called a smart contract trigger. This is where an action on one chain triggers something on Flare.
How Flare Networks is driving the development of real-world applications through its EVM Layer 1 Oracle network and smart contract platform. So we got some nice press coverage here from CoinDesk. Layer 2 networks and scaling solutions have been getting a lot of attention from the crypto enthusiasts and analysts as of late. But what about the much needed innovation in decentralized application functionality, or DApp functionality? The total size of the application-based industry is approaching 500 billion in market capitalization, with DeFi comprising of 48 billion in TVL. But its growth has been limited by factors such as UI and UX, and fundamentally, the lack of utility for most people. To grow further, blockchain needs more applications that are more relevant for more people. One way this could happen is by increasing the variety of securely acquired real-world data and blockchain data available for use in dapps on-chain. Companies such as Chainlink are innovating in the data oracle space to deliver this. Well, let's just pause there for a second and name some of the few things that are different between Chainlink and Flare. Because in a way, they are competitors, but there are certain things that Chainlink will never be able to do that Flare can do. Flare put a blockchain at its core for security, and it put the native token at its core for a Schelling's point, which is rewarding for providing good prices. That's how the probabilistic data from the FTSO comes into the network. FTSOs, we have over 80 of them, and we have over 80 of them because they're incentivized to provide the best data because they earn the native network token just like miners do.
What we call the Flare time series oracle. And that takes the native token, so the native Songbird token, and people delegate to what we call price providers. And currently we have about 86 price providers that are live, and we have about 120 that are registered. So quite a sizable number of price providers relative to basically any other price oracle in the space. It updates every 3 minutes, and each one of those price providers is essentially calling the APIs of all the various exchanges and putting their best guess of the price into the network. And essentially each price provider gets pricing power from the people that delegate the native token, Songbird, to that oracle, to that price provider. And then Songbird aggregates those prices, takes the center of cuts off the tails, and you don't get outliers, and takes the weighted median of that distribution. And it's been live for over a year. It's been really robust.
Interesting.
And frankly, we've done quite a lot of analytics on how it's performed, and it's been a really stable, really valuable price source.
Mm-hmm.
We just wanted to build something for our blockchain that we felt was truly decentralized and best in class. And it's really nice to do this at the network level, where you're actually using the network token to secure a price oracle. The price oracle is only a little bit of what we're doing. I would say the much bigger aspect of what we're doing is the state connector.
Now, the state connector doesn't use value to secure the deterministic data because it uses a group of attesters who are in their own consensus and then are backstopped by the branching protocol and the local attesters, which are the validators of the network. Flare is trying to fundamentally solve one of the most difficult problems in crypto and blockchain to this date. So, back to the article. However, as dapps emerge and daily active users numbers grow, so too will the opportunity for oracles that can trustlessly provide more type of data while facilitating fast, secure transactions at the smart contract execution layer. Recently launched Flare has done just this, building the layer 1 for data, driving the development of more useful real-world applications. Everyone talks about utility. Well, how do we get utility? Well, here's one of the biggest ways to get utility is bringing in better data. Right now, blockchains are difficult to use, and dapps are difficult to navigate. As an EVM-compatible Layer 1 with oracles secured by the network, Flare is built to enable open, decentralized, and safe interoperability between blockchains and also between blockchains and Web2 APIs. Developers need technology stacks to build dapps that can securely access a more diverse array of data. A simple example could be providing decentralized access to the memo field of a transaction on a different chain. This memo field might contain a payment reference that could in turn trigger the execution of a contract. A more involved example could be enabling a trustless connection with a banking API to power smart contract execution. Flare's objective is to enable innovative real-world applications by giving developers access to more types of data in a decentralized manner. Flare's suite of protocols and tools help developers securely acquire time series data, including cryptocurrency price data and event data from other blockchains and Web2 APIs for use in dapps running on Flare. Flare's two core protocols, the state connector, which we just talked about, that's deterministic data, and then Flare time series oracle, the FTSO, that's probabilistic data, assist in operationalizing EVM-based smart contracts and the dapps that depend on them. Data can be provided trustlessly when independent decentralized nodes are incentivized to provide accurate data.
There's lots of different ways you can construct them with various different trade-offs. So for our price oracle, That's kind of like a soft proof. You can't prove something that isn't deterministic ultimately. Like if you say, what is the market price of Bitcoin? Well, it's different on different exchanges. It's different by fractions, and it's different as to when you look at it. So you can't really prove the price anywhere. But what you can do is you can create Schelling point within a properly decentralized oracle, which essentially allows a true decentralized system to come to essentially an agreement that this is kind of roughly where the price is.
In a Schelling system,
FTSO, the pricing has been really very accurate. It is designed to be able to withstand a very large amount of malfeasance amongst the participants. So essentially, it would take a huge amount of corruption in the Oracle for the Oracle's price to become degraded.
That data to be corrupted.
Exactly, because it's all secured by the token. So it's the same idea as how much corruption a network would need, how many corrupt participants a network would need in order to become corrupt. So it's like the idea of a 51% attack. Whereas these ideas are not inherent in any other oracles. They're often trusted, or if they're using their own token on a blockchain, it's very, very much harder to get that level of decentralization. It's very hard to be able to get so many participants. Most smart contract platforms could not handle the number of participants we have and the amount of data we have.
So the state connector, this is what allows Flare to connect everything. Fully interoperable, multi-chain ecosystems require mechanisms to securely query information that is external to an individual blockchain. Such information can include state acquisition, which gives the status of a transaction, including whether the transaction took place and when. An example of this type of data could be triggering a smart contract action with a payment made on another chain. In the case of dapps running on Flare, the state connector allows the network to acquire transaction information from other chains. It allows smart contracts to be self-executing based upon the information brought from off-chain sources. That's huge. We haven't had that to this day. So everyone calls things smart contracts, but we've had pretty much dumb contracts because they can't auto-execute based on the data, because you don't know if it's going to be there in a year or 2 years or 6 months or 2 weeks. With a blockchain in its core, a blockchain is going to be there. So that's something you could count on to auto-execute. So this is why they're trying to be the base layer for data.
So how does Flare's state connector differ from other third-party Oracle services? Like we mentioned, Chainlink and some of the other ones, but maybe give us a little more meat on this.
So, again, it's decentralized. It operates with a large number of participants. It's embedded into the network, so it's part of the network. And this is where it gets its security from. So other Oracle services are, generally, broadly, they don't derive their security from being participants in a blockchain with value at risk. This is a really important factor. Like, essentially, they sit on top of a blockchain, and broadly, that is why they have had to have a centralized model, right? So you've had to basically trust oracles, and the reason you've had to trust oracles is because it's been too hard to engineer essentially a system where there's an economic reason for an oracle not to lie. That's why we've built Flare. We've built Flare to basically be a base layer for data, secured by the layer itself. And I think I said earlier that the most important thing about the state connector is it's not secured by proof of stake.
Securing blockchains and transactions that happen over them can take a number of different forms. The state connector has a binary forking protocol and an additional security measure where individual validators can define local attestation providers. These independent local attestation providers can trigger a validator to branch if a threat is perceived. The validator then remain in a safe, idle state until situation is resolved. Unlike proof of stake mechanisms, attestation providers are not required to stake value, and the security of the state connector is not limited by the amount staked in the system. This is very important. This means that the system is capable of handling large amounts of value, that transactions of all values can be handled securely. This robust, secure, developer-enabling protocol can thus play a significant role in the decentralized economy.
And I think I said earlier that the most important thing about the state connector is it's not secured by proof of stake. So even though to get into the state connector, one will eventually have to put up some stake as being part of a validator, the security properties of the system does not rely on that. And the reason why that's important is because imagine if you have $100 million worth of stake, but you've been asked to confirm a transaction that has a value of $1 billion. The stake over here is nowhere near enough to secure the value here. And so whilst I won't go into it in too much depth here, the state connector has a binary forking mechanism. This allows any minority set within the state connector, so the validators of the network, to essentially, if the system becomes corrupt, to basically say the system is corrupt, we're not approving this new data. Here is a new version of Flare, which does not have the bad data embedded. This is the old version. This is the new version. And obviously, anyone that cares about essentially the data, about the applications that are leveraged from that data, about the value connected to that, they will migrate from the corrupt version to the version that does not have the bad data. So not only do we have the base staking security, we have an additional level of security that allows in a case where the system itself becomes undermined, malicious, it allows the system to essentially rectify itself without causing loss to the applications and the users that are using that system. We're most proud of that because relative to other systems, whether you call it an Oracle or whether you call it an interoperability protocol, everything else is secured just with money. And we think that security premise essentially is fundamentally flawed.
Stake. The second and possibly more interesting mechanism is it has something we call the state connector. The state connector is a deterministic oracle. It's the only oracle in the space that actually has a consensus protocol. So it has a binary forking consensus protocol that uses the network to come to consensus over external data. And this allows Flare to act as an eye in the sky.
Okay. And now on to the second protocol, which is the Flare time series oracle for probabilistic data. Scalable, EVM-based smart contracts require accurate, robust, on-chain decentralized data feeds and secured relay of data. The FTSO is a highly decentralized data feed oracle that supports the provision of reliable price data, with almost 100 data providers incentivized to provide reliable data every 3 minutes. The FTSO will also deliver other off-chain data available for use in on-chain apps, including time series data such as weather or grain or commodity prices for insurance purposes. And just to note here with the 3 minutes, compared to many other Oracle systems out there, 3 minutes is awfully fast. Many take hours. So 3 minutes is where it is right now, which the movement of the prices aren't dramatically moving in that period of time where you got an hour, 2 hours, half hour. That's more of a risk. So 3 minutes is still way above the industry standard for oracles. Everything that's built here is above the industry oracles because there is no other oracle system that is built as a layer 1 blockchain that has 2 oracle systems. So we see FTSO, probabilistic data, means there's no one price for it. So that's why you need these outside entities, FTSOs, bringing in data, and they are rewarded for bringing in that data. A median price is run through, and that's the output of that for the dapps on Flare and those that will use them cross-chain. But it can't be coded in. It's something that's inherently not native to the blockchain. It's bringing in data from outside the blockchain. And now the state connector is deterministic. What does that mean? That's yes or no questions. Did this happen on Bitcoin's blockchain at this time in this account? Yes or no? And it can be proven. So those are the two different things, but they work together. And the state connector does not use value at stake. And that's important because if you have these large transactions, as the financial markets move into tokenization and into DeFi, and you're going to put up some random DApp token at stake, and all of a sudden a $1 billion transaction comes through, that incentivizes some oracle to act maliciously, and they can make, millions off that when they're getting paid, a small amount here and putting up some DApp token that's not even worth 1/100th of the amount of value. So that's something to consider going forward. And up until this date, all we've had is trusted solutions and centralized solutions. So making blockchain more useful. According to Hugo Filion, CEO and co-founder of Flare, we need more useful decentralized applications. Flare is tackling this through data, not just prices, but transaction details, Web 2 events, so that developers can build applications that provide more utility to a larger group of users. There is still a lack of real-world utility being observed at scale in the Web3 technologies, due in part to a lack of securely acquired off-chain data available for use in on-chain dapps. Decentralized access to high-integrity data from other blockchains and Web 2 internet sources enables the creation of new use cases and monetization models. The FTSO and the state connector make more types of off-chain data available for use in on-chain dapps securely, scalably, and trustlessly. So who stands to benefit from the technical advancements in Layer 1 interoperability and Oracle networks? Gains in interoperability and data acquisition and validation mechanisms will be of great help to Web3 developers, especially those focused on Web 2 to Web 3 composability. But developers are not the only ones who will be able to take advantage of improved data Oracle tooling. Participants in data DAOs, so decentralized autonomous organizations, and machine learning practitioners wanting to develop and sell algorithms and data sets or make use of data unions need the means of porting data. The users of both DeFi and NFT protocols also stand to win as token exchanges increasingly take up and make use of accurate, fast, decentralized price feeds. Data oracles and the protocols that power them will play an increasingly important role in achieving real-world utility in the future. decentralized economy by helping developers to obtain securely acquired off-chain data available for use in on-chain dapps.
Done with essentially, if you can bring as much data on-chain as possible in as secure a way as possible, in as easy way as possible, then we think that actually there's a massive proliferation of use cases for blockchain that can happen. Now, we're starting with blockchain interoperability, bridging, relay, messaging, being able to make a payment on one chain that does something on another, being able to make a payment on one chain that does something on Flare. So for instance, with the state connector, great, example use case. Make a payment on the Bitcoin blockchain, make a payment on the XRP blockchain, triggers a smart contract to deliver you an NFT on Flare. Nice use case, like easy to understand use case. And then there's things like token bridging, both for non-smart contract tokens and smart contract based tokens through potentially different protocols. And then, relay between blockchains, both of data, but also, message calling. So allowing essentially an action on one chain to then call an action on another chain.
Which we haven't even seen yet. We have not seen cross-chain dApps in their true form exist yet. Now, with everything that Flare's building, including the data relayer, is going to allow for a single stack, integration to the stack, to be able to create cross-chain dApps. That means it could pull data from one chain to execute a contract on another chain. That's unheard of. It doesn't exist yet. So there's this opportunity here to capture a whole new segment of the market. And this is not something that somebody could just copy with another protocol. You have to have the components in place. And so FLR actually, since its main use case is as collateral, so it says collateral in the layer cake system, in the F-asset system, it needs to have the value. Now, I'm not going to go and say, oh, it needs to have a high value or it needs to have some price. We're not going down that road because nobody knows. But the reason why so much is being distributed is because it's a distribution process of 3 years.
It's been engineered to have high performance as a decentralized cross-chain platform that delivers a set of native and open protocols secured directly by the network. These protocols serve as the foundation for developers to build interoperable and composable applications across chains. Interoperable not only across Web3, but between Web2 and Web3. This means applications are able to be interoperable across many networks and composable with other applications on Flare. In essence, Flare is built to help the blockchain industry scale, acquire more users, and make blockchain substantially better by enabling digital assets and on-chain information to flow freely across all the different blockchains.